Hi! Today we will learn different methods of integration of trigonometric functions. First, let's introduce rational functions of two variables. Function is called rational if it can be represented as a fraction of two polynomials. Here, r is represented as p divided by q. Here you can see several examples of rational functions of two variables. In this lesson, we will find out how to integrate rational functions of sine and cosine. Here are the examples of such functions. The most general way of integration of rational functions of sine and cosine is universal substitution. After such substitution, t equals tangent of x divided by 2. The integral reduces to integral of rational function of t that can always be integrated explicitly. Let's see how the universal substitution works in case when we need to evaluate this integral. After substitution, we get the integral of rational function of t. Then we evaluate it and return to initial variable x and get the final result. Universal substitution often leads to long calculations. These four rules provide simpler ways for evaluation of integrals in the following cases. The first case is when r is odd rational function with respect to sine. Then we can use the substitution t equals cosine of x. The second case, r is odd with respect to cosine. Then we use t equals sine of x. The third case is when r is even with respect to both sine and cosine. Then we use t equals tangent of x. And the last case, when r is the function is a rational function of tangent itself, then we can use the substitution t equals tangent of x. Consider such an example. In this case, function r is even. Thus, according to rule number 3 from the previous slide, we can make the substitution t equals tangent of x. After that, we evaluate all the functions that appear in the initial integral in terms of tangent of x, so in terms of t. So we've got the rational integral here. We will evaluate it and return to the variable x and get the final result. Note that not all trigonometric functions can be explicitly integrated. Some integrals cannot be expressed as analytic functions. Here you see some basic examples of such functions. So if you see that one of these functions is used inside the integral, then you know for sure that the integral cannot be evaluated explicitly. That's all for today. Thanks for watching our video. If you have any questions, you can contact us. You can also download the PDF version of this lesson from our website assignmentforstudent.com. Thanks again and good luck!